Hi, my name is Clara, and I have been working in Python to create an image, a landscape image. I searched up on Google an image of like a landscape because I thought that would be it would be challenging, but not too challenging that I wasn't able to complete it in the time that I had. So I started by creating the background, so the grass and the sky. Then I did the mountains, first starting with these back dark blue ones, and then these front ones that are a little bit more brown. Then I did this, the brown green bushes, and then I did the darker green bushes, and then the trunk of the tree, the leaves of the tree, and then the branches. The tree is supposed to be a cherry blossom tree. It's not really easy to tell because I just have a circle of pink. One of the most challenging parts for me was the bushes because I had to. At first I had to not be as detailed. I just had like a straight line from top corner down, and then another straight line from like halfway through and down for the two bushes, and it didn't really look good or like bushes at all. It just looked like something that was there, like maybe a mountain that was like closer up. And so I went and redid it so that it had the colors, so that it looked more realistic. Also, at first, I didn't have these background bushes. I just had background mountains. Sorry, I just had these dark, like the blue ones in the back here. And so I had to change the program that got me from. So originally, I was going to just start here and do it. I had to change that because I was over here. So I need to move back. I need to turn, and I would say one of the hardest parts is turning so that you go the correct amount, like the correct angle, and you're not turning too far or turning too little that it doesn't line up. Also, I wanted things to line up with this line here, so that was also a hard part about it, making sure it went the right, it was flat and not uneven, and that everything lined up. Another thing that was hard was that I was not able to, at first, fill things. I just had Collab Turtle, and I really needed Collab Turtle Plus. So because I just had Collab Turtle, I was not able to fill. So I had to import Collab Turtle Plus to be able to do the fill. So in the order which I did things was I started by inserting Collab Turtle Plus. I changed the speed to 15 so I didn't have to wait a long time for it to finish drawing because it could take like 2 or 3 minutes if I just had it at a regular normal speed. Then I moved the turtle because the turtle is what actually draws it to this corner, and then I drew the grass, which was just a box that I then filled in green. Then I did the sky, which was just another box that I filled in sky blue. Then I did the mountains, which were time consuming because I had to turn them and make sure they lined up. And then at the end here, I had to make sure it lined up with the grass and wasn't like curved or anything. Then I had to move and do the second mountains. I just added a loop for that, as you can see right here. I just added a loop so that I wouldn't have to repeat the code and have it be longer than it needs to. Then I went over and I did the bushes. Turning here again was really hard. Then I did the kind of tan bushes first, and then the green bushes, and then I did the tree, starting with the trunk and then the leaves and then the branches. So if I run this, I'm actually going to make the speed a little bit slower so that you can actually see it change. But you can watch as the turtle right here actually draws everything. There you are.
Yeah, and I really didn't like it.
So that's my project that I've been working on. I hope you like it.
Hello, my name is Connor Garrett, and for our project we chose 3D terrain.
Hello, my name is Jonas, and I am the partner of Connor. In this project, we decided that we wanted to create 3D terrain to represent a mountain range. So what we did is, first of all, use the 3D terrain libraries, and we used the libraries that the teacher gave us to install, and we created different mountains down here by telling it that, okay, so this one's the normal one. It's the one that's right here. And so we told it, so in this case, x should be -6. So it would set x to 6, which is why it went there. And we just did that till we felt like we created a small mountain range.
So x minus 6 and y minus 0 and x minus 6, y plus 6, they all represent a spot on this kind of plot. So like x minus 6, y minus 0, so y minus 0, and then x minus 6 will equal this mountain range right here on the plot.
We had to import NumPy, which is Python's library that defines many numbers, and also defines like the x astra, which is x to the power of 2. Otherwise we wouldn't be able to use these and it wouldn't understand it.
So down here, this is how it projects it into 3D. So it goes projection and then 3D. So that's how it projects the mountains.
We had to define x, y, and z, which we changed. It used to be -1, 1, and 100, but we decided we would make it -4, 8, and -8, 4 to give it a like symmetrical or sort shape. Because you see, if I set it to 7, for example, it will just like,
It'll make the mountains a little bit sharper
yeah,
and uneven.
like for example, I'm gonna set this back to 4. If we decided to take this one, made it 13, and this one, and made it like -2, for example, the mountains would start looking like this. And instead of the 5 that we created, because these aren't in the range of 13, it won't create these 2. And these right here define where the location is supposed to be. And if I set this to -11, it'll do this. I'll just change. I'm gonna let Connor speak a bit now. Set this back to, was it -6?
X minus 6. So this is our 3D terrain project. I'm Connor.
I'm Jonas.
And this is our video.
Thank you for listening.
My name is Cameron McLean.
And my name is Grant Long.
We made a snake game using Python. Python is a coding language like Java or C#. We found a website called Replit to work on this project together. This website also gave tutorials on how to make easy things, like the game Snake. There was also other games that we could have made, but we decided to go with Snake because we knew it, and it's pretty fun.
We followed a tutorial, ended up with a finished game that we could play based on the tutorial. We changed like a good bit of the code, so it's more of what we made and not what the tutorial was. Then we feel it's a little bit better now. We also changed colors, like changed colors of the snake, the background, the food. Made the food shaped like an apple, this red circle, equal apple. And we changed a couple of the codes lines around to make it like a little feature that you can see as the food moves a little, like doesn't teleport, it just glides across the screen.
For people that don't know, Snake is a game you play by moving a snake around on a screen using the arrow keys while trying to eat food. The more food you eat, the longer the snake you get. This can be bad because if you run into yourself, you lose. And also if you touch the barriers, then you also lose. So pretty much the longer the game goes on, the harder it gets. Here's some example gameplay of the game.
Some gameplay, quality gameplay right here.
Yeah, I'm trying to slow this.
I'd definitely have that high of a high score.
Good enough.
Alright, now, there's parts of the code, like, in this section, you can see there's, this line is the background color line, so we could make it yellow, and if we stop running it and then run it again, we get a yellow background. The head shape is currently a square, but what if we want that a circle? This line right here, this allows us to change the shape so that now you got a little circle head. We can also change the color of his head using this line, which we would say.
Sorry about other people talking.
We can't record anything else. And now, that orange head.
And more about the code is that here is the food and how we made it. We have it as a color red and it's shaped as a circle.
How about we make it a triangle and color black?
Triangle
That's
and black.
boom. Boom.
And so here is the text. This is how we made movement in this area where my mouse is. This is the arrows, or arrow keys and their functions. This is the boundaries and how you can lose. This is how you gain segments and eat the food. This is actually making them and placing them around. And this is actually losing, and this updates the score depending on if you lost or gotten more segments. And that's pretty much the end of our presentation.
Alright, well, I guess
I'm Griffin,
I'm Dave Sunia.
and for our project, we decided to make a pixel art of the Mona Lisa. So we started this project by importing Colab Turtle Plus, which is a program that allows us to draw using code. And so the first step in this process, we had to make a function, which is basically every time I write square, it does all these lines of code. And so what this does is it makes a square and then uses the fill commands to fill in the square with a certain color that we pick. And so then we have to make a new row using commands to move the turtle around and down to a new line so that the code can continue running for however many pixels the artwork is. So because pixel art is just a bunch of individual pixels colored different colors, we have to make the square function a color variable so that we can input all the colors for each individual pixel. And we did that up here through all of these color values called RGB values, which we assigned to numbers and then had the code print them out in a grid that forms the Mona Lisa.
Yep. And for the color values, we basically put the image inside of a color picker, and we took each pixel and extracted the color from each one and put them up here so that when the turtle would go in, so which we ended up with 767 colors, each different. And these numbers up here correlate to these colors so that the turtle knows to go in order of each line, and he'll use the color for each number here. Yeah.
So each of these colors is in a line of 24 colors, and it goes down 32 lines, making it a total of 768 pixels. Doing all the colors and picking the RGB values was probably the hardest part or most time-consuming part of this project, because we had to go through each individual pixel one by one until we had all the colors to print the image. So the final part of this code is this little block down here, which basically runs all of these functions at once. So this is the main starting command, and then it does a loop here, which draws the square for the color, and then starts a new row, and then does it over and over again until all of the image is completed. And also at the start, we have this piece of code initializes the turtle and begins the program. And here this sets the speed so that it's not incredibly slow and takes forever to build. And then this variable right here is the side length, meaning we can change the side of each pixel easily without having to go through all the code and change it everywhere. And finally, this little 3 lines of code moves the turtle from the center of the image around here up into this top corner so that we have more space to work with for making our pixel art image. So that is our project, and thank you.
Keep coding, guys.
Hello, I am Jacob Riley, and due to my partner DeHarry not being available at the moment, I will be solo reading our entire project. This project in question is the weather readings from 1972 to 2022 of Darlington, South Carolina. To start, I've pulled my data. I've created a token from the given website, then pulled it in, as well as Darlington station ID, and I've implemented it into Python code. I have also imported the requests, pandas, which is known as PD, JSON, numpy, which is known as NP, and from datetime, I've imported datetime. All this code here is used to pull the average temperature, minimum temperature, maximum temperatures, precipitation, and the dates from 1972 of 2022 of Darlington, South Carolina's weather. And it has pulled every single recording of those 5 factors. And if you look here, this displays and plugs in all that data from the previous cell of code. And it is focusing mainly on the minimum temperature, the maximum temperature, and precipitation. All this code here is made to define linear. All this code here is used to create a scatter plot to display many factors. The first of which being the factor of minimum temperature and maximum temperature, shown on a scatter plot, with x being dates going from left to right, and y being temperature. And as you see, it has this effect. And this one I plugged in minimum temperature compared to precipitation, which looks quite different. And doing this, I can compare it to the maximum temperature, giving a graph like this, which just does not look like it's very correlated. And thus, from me and Daharia's findings, as the minimum temperature increases, the maximum temperature increases roughly the same time. And I have also found that there is no correlation between the precipitation and minimum temperature, the precipitation and the maximum temperature. That concludes me and Daharia's findings from 1972 to 2022 of Darlington, South Carolina in the USA's weather patterns and recording.
Okay, so we made a program to make completely random 3D terrain. And as you can see there, it is random in 3D terrain. It just got re-rolled and now it's random again. Okay. And so the first thing there is we imported all the libraries that we needed, which is just extra code for the program to run correctly so it doesn't break. And then the next thing is another import of a random list of numbers. And you can see that it is a random list of numbers. And it generates randomly. And so the next thing is the x and y variables are random from -20 to 20, right? Yeah. And that was where x and y were defined. And now it's your turn.
Okay, so the mesh grid is the plot that it's on, and we limited it so it goes from -10 to -10 on each side. So you can see here in the code that's where that works. And then we plotted it so that you could see it. And then we made our model visible here, where it's on top of the mesh grid now. And then we set the camera view so that you could see it from the right angle. And then here we just added color to our model so it looks more like terrain. And yeah.
This could be used for like video games and probably other things, but mainly video games. And so now it's example time. It's time for an example, yes.
Okay, so like things like Minecraft and stuff, obviously you need to generate random terrain because each world is different. So this is something that could be used for. And why did we decide to do this?
We decided to do it because it sounded interesting to me, and I don't know if it sounded interesting to you, but it's interesting to me. And so I made one also, but it wasn't as good. But it's gone through multiple iterations now, because we've had to change things, like redefining some areas and importing other things needed.
Yeah, so many times we would make it and it either wasn't set at the right viewing angle, or it was, we were making the wrong, we were making things like the mesh grid random instead of the model itself. So we learned to fix that, and now it works pretty well.
And another problem was that sometimes it wouldn't appear at all, and we'd have to re-randomize it so that it appeared. And then other times it randomized wrong into a negative number and then didn't work at all sometimes. So we've had difficulties. And it took us like 2 days to do this.
Yeah.
Right? Yeah, about 2 days of work. So, I'm running out of things to say. It's your turn again.
Yeah, that's our project. Yay!
So, using a program called GoSciTech, we were able to program using Python, the coding language. We were able to program a set of movements to draw a famous picture, Starry Night specifically, by Van Gogh. And the code to do it was super long. It's just this super long list of code. Just a slight curve is at least like 20 lines. It's crazy. And that main structure in the middle there, which I still have no idea what it is, has a bunch of strange shapes. So it was hard to program. The spirals, which were very nicely created by Sawyer here, the large one, the moon, up in the top right corner is like 6 lines, which is crazy. And it was tedious, but being my first large-scale coding project, it was really interesting and very fun to mess around with. And I hope you had as much fun as I did. Yeah. And that's kind of all I have to say on this project.
Hi, I'm Shatakshi. I'm Surya. And we made a survey on Google Form and tested our class. And we used the data to make scatter plots and compare the relation between them. And this is the first scatter plot. And as you can see, we first imported the NumPy library, and then we imported matplotlib, which is another library. And then this is the data we got for height, for age. And then this is the data we got for height. And then, so the x value is the age and the y value is the height, and this is the scatter plot. And then we used the code below over here and made the line of best fit. And a correlation can be between 0 to 1, but a good correlation is closer to 1. And as you can see, the correlation here is 0.04, which is closer to 0, so this is not correlated.
On this scatter plot, we're comparing how many siblings a person has to how often their mood changes in a day. And on this side, we have how often their mood changes, and on this side, this is how many siblings they have. And this is the line of best fit that we found, and the correlation is 0.02, which is really close to 0, so there's a correlation between those.
For this one, we compared the amount of coffee someone drinks to their sleep time. Okay, we thought that there's going to be a correlation, but there wasn't. So first, we imported the NumPy library and the matplotlib library, and then this is the coffee count, and this is the sleep time. X value is the coffee count per day, and Y value is the sleep time, and this is a scatter plot we got. And then we used this code and got the line of best fit, and there's no correlation because it's 0.07, which is closer to 0, not 1. So the amount of coffee someone drinks to their sleep time is not correlated.
On this scatter plot, we compared what grade someone was in to their age. We assumed there would be a correlation because most people share the same grade when they're on the same age. And this is our scatter plot that we got. On this side we have their age, and on this side is their grade. And this is our line of best fit. and the correlation was 0.68, which is pretty high, so there is a correlation.
This was the last one we did, and we used the data to make a scatter plot, and we compared camp experience to grade level because we thought there might be a correlation because some grade levels might like the camp better or less. So first we imported the libraries, both of the libraries, and then this is the data we got as a rating out of 5. And this is the grade level people were in. And this is scatter plot we got. And then we used the line of best fit. And the correlation is 0.01, which is really close to 0. So there's no correlation between how much someone likes the camp. So yeah, we're done.